Hello, welcome to 1.7, the log laws. Alright, so here's a question. What power must 2 be raised to in order to get 8? So it'd be like 2 to the x power is equal to 8. Whenever you say like what in math, call that an x. So it's this one's pretty easy. X would be 3, right? So 2 cubed is 8, right? And this one, what power must 2 be raised to in order to get 16? So we'd write that as 2 to the x equals 16. And it's, in this case, it's 4. 2 to the 4th is 16. And so this begs the question, what power must 2 be raised to get 10? Well, 10 is between 8 and 16, so it would make sense that this value here would be between 3 and 4, but it's, I mean, how do you figure that out? How do you find out that value? You could start to just kind of, you know the value is between 3 and 4, so you could do like 2 to the 3.5. That's too high. 2 to the 3.2, too low. And so you'd have to just keep narrowing this down, and it'd take a long time. Getting closer. Ooh, too high. So anyway, this was a problem in mathematics back in the days of the old. And they had to solve this problem. So they came up with this thing called logs. And the logarithm, we say in base a of b is the power that a must be raised to in order to obtain b, written as the following. Alright, so for all of these up here, so if we're going to say what power must 2 be raised to, so log 2 8 is equal to x, like that. Log base 2 of 8 is x. And in this one, we would say log base 2 of 16 is our x in this case, and in this case, we would say log base 2 of 10 is x, like that. And we can actually plug that into our calculator. You have to go find logs. So you got to actually press catalog, just right here, and you can press L, which will take you down to all of the L's, and log base, like that. Log base is right there. All right. So if we want log base 2 of 10. So we know the answer is between 3 and 4, and it's ended up being 3.3219 in this case. 3.3219. Alright, and if you can check that by saying 2 raised to that power is 10. Alright, so that's how it works. That's how the logs work. Or it gives us the ability to find these exponents that are between the integers. So 3, 4, 3.3219. So it saves mathematicians quite a bit of time. In general, here's what this means. A raised to the x is equal to b implies log a of b is x. Now, in this curriculum, we narrow it down to we only work with base 10 and base e. Base e is called the natural logarithm, and base 10 is just the standard log. Alright, so for us, 10 to the x equals b implies log 10 to the b, log base 10 to the b equals x. And also, log base 10 is the standard, so you won't see log base 10, you'll just see it written as that. So when you ever see just regular log, it's implied base 10. Okay. Last little thing is that if you have log base 10 and the base of something is 10 like this, these cancel out. So log base 10 and then the base of 10 cancel out. And similarly, 10 raised to a log also cancels out. So we'll do some examples. And here we go. Now what is the logarithm in base 10 of 1,000? So we could write that as log of 1,000. Or another way of saying that, okay, so that's equal to x. So another way of saying that is 10 to the x power equals 1,000. And I think you'd understand why x is equal to 3 here, because 10 cubed is 1,000. So in this scenario, what is the logarithm in base 10 of 1,000? The answer is 3, because 10 to the third is equal to 1,000. Next, what is the log of 0.01? So we don't necessarily need a calculator. 10 to the what power is 0.01? How many, let's see, I think we'd agree that that would be -2. If you raise 10 to the -2 power, you have to move the decimal 1, 2. So it moves it to there. What is log base 10 cubed? Okay, so remember, log, that is a base 10, that's a standard. So what's happening here is when you have a base 10 on the exponent, this log cancels out that 10. And you're just left with 3. That's what ends up happening. Next, what is log 10 to the x? Once again, this log cancels out that 10. That's the only time it happens where they cancel out, and you're just left with x. What is the log of 34? In this scenario, you have to just use your calculator. Alright, so we're not dealing with base 10, nothing crazy going on here, but we're just going to have to use a calculator for that one. So all you have to do is hit the log button. It's right there. That assumes base 10, and then you just plug in 34. Alright, so 1.53 roughly. 3 sig figs. Next, what is the log of 2? Again, put it in your calculator. 0.301. What is the log of 20? One more time. 1.301. Interesting. 1.301. Alright, so next question. Explain why the log of 20 is equal to this plus 1. How are these related? How is log 2 related to log 20? Why does it end up being this plus 1? Alright, so let's work with the log of 20 here for a second. Now we can rewrite the log of 20 as log of 2 times 10, like that. Which we can now rewrite. So now this is getting quite tricky here, but we can say that 2 is the same as 10 raised to the log of 2, because these cancel out. Like up here, we said that 10 raised to any log will cancel out. So this is technically still 2. So this was 2, and this is actually 2 still. Okay, so now we're getting to now we've got 10 as a base for this exponent. We've got 10 for a base to this exponent. And now we can combine the exponents using the exponent laws from the past lesson. When you multiply exponents with the same base, you add you add the exponents together like that. And now, if you've got a log of something with a base of 10, these cancel out. So those cancel out, you're left with log 2 plus 1. So there you have it. So the log of 20 is equal to the log of 2 plus 1. You can see that right here. Log of 2 is 0.301. Log of 20 is 1.301. Alright, next, use a calculator to write the following in the form 10 to the x, where x is correct to 4 decimal places. Alright. So we need to write this as 10 to the x. Alright, so 10 to the what power is equal to 8. So we can rewrite that as log base 10 of 8 is equal to x. And so you just have to plug that in your calculator. Log of 8. Like that. 0.903. 0.9031. We can check our answer. If you do 10 raised to that power, like that, it's 8. So same idea here. Once again, we're asking ourselves, 10 raised to what power is 800? So it's log of 800 is equal to what we're looking for. So plug that in your calculator. Log of 800. And it's 2.9. So x is 2.9031. We can check that. 10 raised to that power is 800. Alright, so we're just looking at the log of 0.08 here. 10 raised to what power is 0.08? It's going to be quite small. So the log of 0.08. Negative. Ooh, that's interesting. It's a negative number. When it dips below 1, it becomes negative. So negative 1.0969. And then we'll check our answer. 10 raised to that power is 0.08. Can you imagine doing these calculations where something like this turns out and you don't have the log function of your calculator? Like, I don't even know how you do that. The magnitude of earthquake is given by this. 2/3 log E is in energy in joules divided by 10 to the 4.8. Just the fact that we live in a universe where we can model things with, we can model earthquakes with equations and make sense of them from earthquake to earthquake based off of an equation, and it's a consistent equation from earthquake to earthquake. Like, why is there even an equation? Why should there be? It's just crazy. So find the magnitude of earthquake which releases 5.1 times 10 to the 10 joules of energy. That is a large number. That's 5. That's 10 zeros, right? I guess it'd be 9 zeros, but alright, so all you have to do here is plug in your calculator. I'm going to make sure my parentheses, so 2/3. You can use the division button as your fraction. That's how you do that. And then log. And then they already gave us parentheses, so now we need to do, I'm going to put for another set of parentheses and do 5.1 times 10 to the 10th. I'm going to close that. Whoop. Like that. Close that. That's the numerator of my log. And then I'm going to divide by the denominator. I'm going to close the parentheses of that. So I think I should be good there. And that would be a 3.9. 3.94 magnitude earthquake. Next, how much energy is released by a 4.3 magnitude earthquake? So this is where we're going to take 4.3 and solve for this. So, this is going to be tough for you. You have to remember back to your log laws from algebra class. And I'm going to run out of room here, so I'm just going to start it over again right here. 4.3 is equal to 2/3 times the log base 10 of e over 10 to the 4.8 power. That's right. Alright, so first thing we do is we get rid of this 2/3. So we need to multiply the 3 and divide the 2. So I would just do 4.3 times 3 divided by 2. Right? It's like multiplying by 3 over 2 instead of 2 over 3. So you get 6.45 equal to log e of 10 to the 4.8 power. Alright, now how do you get rid of a log base 10? To get rid of a log base 10, you have to raise to the 10th like that. Alright, so we can get rid of this. So those now cancel out, and now I've got this over here. And that's going to be probably a pretty big number. Yeah, I'm just going to keep that as 10 raised to the 6.45 in my calculations. So there we have it. And now all we need to do to solve for e is multiply that over. So just multiply this over to the other side. So take your 10 to the 6.45 and multiply it by 10 to the 4.8. And actually, since we're multiplying and they got the same base, you could just add those together. 6.45 plus 4.8 is 11.25 equals e. So there we have it. We'll keep it as that. 10 to the 11.25 joules of energy is what a 4.3 magnitude earthquake is. So we did quite a bit of, we actually did some algebra there. That was fun. It's nice to do algebra every now and then. And moving on, the natural logarithm. Let's see if I can get this all in 2 minutes. Log e. Log base e. Whoops, my formatting didn't work very well for me there. The log base e, also known as the natural log. Now explain to me why we write ln instead of nl for natural log. But anyway, there it is. Log base e. It's my favorite. It's one letter less, so it takes less time. So, for example, find the following. This is the log base e of e raised to the third. So these cancel out. And that just ends up being 3. Next, we can rewrite this using our exponent laws. We can take this e to the 4th on the bottom and move it to the top. And when you move things from top to bottom, the exponent changes sign. So that's just -4. And then in this case, we can think of this as e the natural log of 5 squared. Like that. Because when you multiply exponents, it's like raising a power to a power. Let me write that one more time. A little better. There, that's better. This is like a power to a power. So when you have a power to a power, you just multiply them through. And so these cancel off, so you're left with 5 squared, which is 25. Alright, I'm going to run out of time, but I think we got it from here. Rewrite the following in the term e to the k. So e to the k is equal to 50. What's the natural log of 50? The natural log of 50, 3.9. So e to the 3.91 is equal to 50. So k is